Hello, good morning, friends. So, today we are going to see a topic called as particle swarm optimization. In general, we call it as PSO. So, the swarm intelligence, as per Bonaview, what he said is the emergent collective intelligence of groups of simple agents. So, the swarm means we call it as the simple agents that form the network. So when you see the characteristics of swarm, so we can see composed of many individuals. So there will be many individuals, they just form a group, and then based on the group, it collects or it go and search a particular solution, and that's how the way the optimization works. Individuals, all the individuals are seems to be homogeneous. Homogeneous means you cannot mix up different birds or different swarms or different agents. All the agents are analogous, or they should be homogeneous. Local interaction based on simple rules. So there will be simple rules they just form, and locally they can interact together to each other based on some simple rules. And self organization. So there is no centralized control here. So everyone is organized as per the rules framed by the swarms. So there are multiple algorithms available in swarm intelligence. So one thing is particle swarm optimization. Next thing is ant colony. We call it as ACO. Then ant bee colony algorithm, ABCA we can see. Then we have an artificial immune system algorithm, AISA. So these are the four different things available. So in this lecture we are going to focus on the particle swarm optimization. So when you see the search techniques, so there are different stochastic or random search techniques. So generally these kind of algorithms deal with the stochastic process. That means that usually we try to search a random search so that we will get a better solution. So for that we have swarm intelligence. So the group of swarm or group of agents, they just intelligently find out a particular way. Then we use genetic algorithm based on inheritance, then differential evolution and simulated annealing. So these are all some of the properties of this search techniques. So components of search techniques, when you see the search, how the search technique is evolved is, first thing is we have an initial solution. Second thing, we have a search direction. Third thing is update criteria. Fourth thing is stopping the criteria. Now you can see the initial solution means first we try to find out the location where the solution is available. That's called the initial solution. Next thing is the search direction, on which direction you want to search, that we have to frame it. Then update the criteria to search better and to search deeper. Then finally you can stop the criteria to find out the better or a good problem or a good optimal, near optimal solution. All the above elements can either be deterministic or stochastic. So they can be either randomized or deterministic, or it will be population based or single points. So population based means a group of targets or group of places, where group of a population where we can find out the search space, or it could be a single point where all of them will go and find a better solution in that. So here we have a heuristics. Heuristics is just the approximation. So the approximation says that they aim to find a good solution to a problem in a reasonable amount of computation time. So we have to see that the computation time should be a reasonable amount or a minimal amount, and within that minimal amount we have to find out a good solution. That's what here the heuristic says. But the goodness of the efficiency, there is no guarantee on the goodness of the efficiency. That means we could not expect the better efficiency and the goodness of the particular solution what we got. So this is called as the heuristics that we would like to fix in the particle swarm optimization. So when you see the meta heuristics here, so here it is for exploration and exploitation of the search space. So if you know that there is a solution, so how will you explore the solution? How will you exploit the search space for a better solution? So that's what here meta heuristics means. So if you see that these are some of the algorithms in meta heuristic evolutionary, where all the algorithms what we are going to see, and simulated annealing and taboo search. So anyway, these are all not included. So we are going to focus mainly on the swarm intelligence. So fundamental properties of meta heuristics here is meta heuristic are strategies that guide the search process. So you are going to reach the search process for finding a good solution. The goal is to efficiently explore the search space in order to find near optimal solution. So we are going to find out the near optimal solution, not an optimal solution, but a near optimal solution. So usually meta heuristic algorithms are approximate and usually non-deterministic. So they are all generally randomized and they are all only approximate only. There is no accuracy involved in it. Mostly they are, and they are not problem specific. So it is not like you have a problem statement and for the problem statement we are going to find it out. It is not that way. It is to find out there is a problem. For the problem you want to find out a near optimal solution. So that's what the fundamental properties of this PSO. Now here this is what the outline. So you can see here, this is the particle swarm optimization. See the flock of birds, they just fly together to find out the either during the evenings they just find out the nest where the nest is, and during the daytime they want to find out where is the food. So this is how the way the PSO works here. So the PSO is a population based search method with the position of particles representing solution and swarm of particles as searching agent. So swarm of particles as searching agent and the position of the particle representing the solution. PSO is robust evolutionary optimization technique based on the movement and intelligence of swarms. So it is a movement and intelligence. So not only they move, they also have some intelligence in finding out the food. So PSO find the minimum value for the function. So it just find out the minimum value. It is not a maximum value, it's a minimum value by which the solution is optimal. So now you can see here, there are two parameters here. Bird is a particle and food is a solution. So they are going to find the food, that is a solution, and bird is a particle, that is a swarm of the swarms generally we call. So that is a particle here. So we have two parameters, one is a P best, another is a G best. So P best means the individual particle best and G best is the global best. Global best means together, all of them work together. For that we find out a value called as G best, whereas P best is individual. So generally we call P best is the individual goal. So as an individual, what is your goal? That is P best. G best is as a group, what is your group goal? So that's what here, or we can call the global best, there is a G best. So global best and the particle best. Now the best solution achieved so far by that particle and the best value obtained so far by any particle in the neighborhood of that particle. So this is called as the PSO search scheme. So the PSO uses number of agents, that is particles, that constitute a swarm flying in the search space looking for the best solution. So that is what here. So that is what the PSO search scheme. Each particle is treated as a point in an n-dimensional space which adjusts its flying according to its own flying experience as well as the flying experience of other particles. So it is like not only flying on its own, it has to bother about the other particle flying experience also. Based on the intelligence only, they find out a best solution out of it. Now we can see here, in this position, this is the position X when the birds are flying. This is the personal best and this is the global best, and the new velocity is like this. So this is how the way the particle swarm works. So now for example, if you see a flock of birds flying in this direction, usually you can see in the evenings when the flock of birds flying away. So you can see that this is how the way the birds fly. Okay. So you can see that the group of birds, so this is the velocity direction, this is the velocity, the new velocity what they want to fly, and the individual velocity, this is what the individual, the wings flapping of the wings. So this is what the personal best. So this is the P best and this is the G best. So this is how the way the particle swarm optimization works. Now we can see the objective function are called the fitness function. Generally we call the objective function or the fitness function here. So you can see that x of t plus 1 is the next position, x of t is the current position, and it is a new velocity for the next position. So that means the formula here is if you want to move from one position to another position with the available given velocity. So that's what here PSO informs. So v of t plus 1 will be the velocity to attain a new position, x of t is the current position, and x of t plus 1 is the next position. So this is how the way we can able to model this particle swarm optimization in our softwares or whatever, the mathematical model. Now when you see v of t plus 1, how to calculate the next velocity in a model? So it is something like this: w into v of t. V of t is the velocity of the particle at time t, w is the inertia weight, that is the weight of the particle, then c1 and c2 learning factor, accelerating factor. If the learning factor is too high, that means the learning factor is too high, acceleration is too high, means the velocity also too high, so they will reach the solution in a shorter computation time. If the learning factor is small, the computation time will be prolonged or it will be delayed. So that's what C1 and C2 do. And for that we have a x p best and x g best. So minus x of t. So that means at every location we have to find out the individual particle best as well as the global particle best. We have to find it out. So that's what the values are given here. So now this is the alpine function, what we call for the particle fly and search for the highest peak in the search space. So generally they just search the highest peak in the search space. So for that, this is the formula just given. So this is an alpine function. Whenever the birds fly, so they just wanted to search the food particles only on the highest space possible. So that is also, we also will be trying to find out the optimization problem solution for the highest peak in the search space. Now this is what the algorithm says, the PSO algorithm pseudocode. So now the input and the output. So the algorithm has to be written like this. So input is randomly we initialize position and velocity of particle. That is the position and the initial position and velocity of the birds. Generally we call. So x of xi of 0 and vi of 0, the velocity and the position. Output will be the position of the approximate global minimum x. That means at what location everyone is going to assemble to find out the solution. So that is what the output we are going to use it. So now the algorithm says while terminating condition is not reached. That means while we have not reached the condition for I equal to 1 to number of particles. So that means for the I equal to 1 means starting from one bird to all the particles. That means all the birds. Do calculate the fitness function f. So already we have calculated the fitness function there. You calculate the fitness function, then update the personal best and the global best of each particle. So that means what is the global best and what is the personal best. So we will be keep on computing at every instance of time or during every iteration we have to compute it. Then update the velocity of particle using equation number 2. In the previous slide we have seen the equation number 2 where v of t plus 1 equal to w, the inertial weight, into the learning factor, and so that formula we have to find out. Then update the position of the particle using equation number 1, because after we compute the p best and the g best, we will be computing their next position. So then end for and end while. So that means if you keep on doing this complete PSO optimization, you will be reaching the highest peak possible for a solution. So for the kind of birds it will be the food, but for us it will be a best solution that will be available, a near optimal solution. So if you see that there is an experimental result which was conducted in MATLAB. So the PSO clustering algorithm and k-means were tested. So k-means means the nearest means algorithm were tested using 3 type of dataset: large dataset, small dataset with noisy and outliers. So outliers means, suppose for example this is outliers. So if you have a linear curve, so this is how the way the points are accumulated over the, so there will be some points available here, some points here, some points here, some points will be available. So these are all called as the outliers. So outliers means they were not part of the, the average solution, but they will be moving away from the average, but still they also will be part of the system. So that is nothing but outliers, and there will be some noisy data. Noisy data means irrelevant or suspicious data that has. So 3 kinds of data set have been used for this experimentation. Now we can see PSO generate high quality clustering. You can see that how the PSO generates. So here the PSO clustering. So all the red color birds they form, all the pink color birds they form, all the blue color, all the dark blue, black, then again light red and yellow, so and green, and all these things have been formed in this using MATLAB. Now PSO generate high quality clustering, the same clustering. Here PSO fitness at each iteration. So for the each iteration how the fitness function, and finally you can see the how the fitness function evaluates into a constant value. So this is the near optimal solution. So the fitness function says that this is the formula here: sigma j equal to 1 to k and sigma xi of element of cj and xi minus mu y. So this is what the average, mu y is nothing but the average, and this is how the way they just find out the fitness function of the PSO. Now compare this against the k-means clustering. You can see here the k-means terminated local minimum. So here you can see that somewhere here the green color dots are here, and here this green and this green there was nothing have been found, and blue and yellow has been mixed together. So you can see that blue and yellow mixed together, and these two comes at this clustering here. So like this, and k-means generate empty cluster. So at times k-means also create an empty cluster. Empty cluster means one element which is not part of any of these things, and they mix up with other clusters. You can see that the pink and the black have been mixed together, and they never form the clustering. So this is one kind of a k-means clustering. But here PSO with the generate 9 clusters and k-means cluster with the 9 clusters. You can see. So here the PSO completely is just formed the 9 clusters as per their the P best and the G best. That means everyone forms their they just part of belonging to the same cluster. Each birds or each particle form in the same. But in this case you can see here there is a green color which is not part of the cluster, any cluster, and there are two colors, two heterogeneous group mixed together. So again, but still k-means also a better solution, but occasionally you will get this kind of clustering. We have to discard or we have to recompute it. So that's how the way k-means clustering works. So in this example here, PSO clustering has a better comparison compared to the k-means clustering. Now you can see here, PSO terminated global minimum and k-means often terminates local minimum. So here the global minimum we can see here, the PSO clustering says that all blue color they form in a concentric circle, all pink color or green, and then all red color. But say in the k-means clustering here, you can see here the green color forms like this, and this red color forms like this, and blue color forms like this, and pink forms like this. You can see that the k-means often terminates at local minimum. This is nothing but the local minimum, and here it is the global minimum. So global minimum. So both are equally good, but when they see the cluster here, this cluster is globally just better replaced, and then near optimal solution we got. But in the k-means clustering also it's good, but it is on the local minimum. So it is terminating on the local minimum. Still all the four clusters are away from each other. Away from means they are just grouped as per their coloring structure or as per their homogeneous structure, but the cluster is not at a local minimum. So this is how the way k-means cluster works here. Now PSO cluster does not affected by noisy and outlier. So here in the noisy and outliers here, now here this is one kind of outlier, this is one kind of a noise. So you can see that the PSO doesn't have any effect on this noise and outlier. They are being completely eradicated from the system. But k-means clustering, it also includes the noisy or the outliers, whichever it is given in the data set. So you can see here the k-means affected by noisy and outlier. So you can see here the k-means, there are some noise and outliers here, and you can see this is how the way the k-means work, and this is how the way the k-means work. But you can see in the PSO versus k-means, so PSO seems well organized, and it didn't bother about the data and the outliers, but whereas k-means affected by the noisy data and the outliers. So for the k-means clustering, you have to give the data in such a way that you have to avoid the outliers and the noisy data. So conclusion here is the swarm intelligence is population based search technique. PSO is robust stochastic optimization technique and can be applied for data clustering. PSO clustering algorithm avoid problems that arise with k-means clustering, such as terminating at local minimum, generating empty clusters, and sensitivity to noise data and outliers. So this is the conclusion of this PSO. So these are some of the references. So when you see that PSO as well as the k-means clustering, PSO outlived k-means clustering. So PSO is greater than k-means clustering. Thank you.